Hello and welcome to In Depth. I'm Tina Jha. India's first manned mission to space is well on target. According to the Indian Space Research Organization, a budget of 10,000 crore rupees has been set aside for putting the infrastructure in place. The first unmanned mission of Gaganyaan is slated for December 2020. The second one will also be an unmanned journey in July 2021. The manned mission with astronauts comes next in December 2021. The indigenous mission will be assisted by a few countries that will select and train the astronauts. India's strategic partner Russia, which is a world leader in space program and technology, is offering its semi-cryogenic engine technology and critical components for the human space capsule. Discussions are still underway and an agreement is likely to be reached in the next few weeks. Today's In Depth talks about the semi-cryogenic engine technology and India's partners whose help and expertise will be used in India's first manned mission to space. In addition, we'll also talk in detail about the Gaganyaan mission itself that will make India only the fourth country in the world after Russia, the United States of America and China to send humans in space. After the successful soft landing of Chandrayaan-2 on the lunar surface on 7 September, ISRO's next big project will be Gaganyaan, India's first manned space flight. The space agency has inked a deal with the Russian Space Agency for the training program for the project. Talks are now underway to supply space suits, crew seats, and also windows for the selected astronauts. Most importantly, Russia has also offered its semi-cryogenic engine technology and critical components for India's human space capsule. Russia has offered its semi-cryogenic engine technology and critical components for India's manned mission to space, Gaganyaan. ISRO Chairman K. Sivan has revealed that Russia is offering its semi-cryogenic rocket engine technology to India under the Make in India program. This means that the rocket engines can be made and used in Indian rockets. While discussions on this are still underway, the ISRO chief confirmed that Russia will train Indian cosmonauts for Gaganyaan. Russia's state-run space corporation Roscosmos will train 4 Indians at the Yuri Gagarin Cosmonaut Center under a contract signed between Indian Space Research Organization and Glavcosmos, which is a part of Roscosmos. Glavcosmos will help ISRO to select, test, train and qualify Indian astronauts and involve the Yuri Gagarin Center and the state-run Institute of Medical and Biological Problems. The two countries are also negotiating supply of space suits, crew seats and windows for astronauts who will be a part of the Gaganyaan mission.
The Russian Space Agency has come and offered ISRO that it will share its semi-cryogenic technology to India. This technology would be one thing that the ISRO is attempting to get itself. It is very important because if you want to go to the next level. I mean, we have currently 2 rockets. One is PSLV, the other is GSLV. PSLV doesn't use much of cryogenic at all, but GSLV, the last stage is fully cryogenic engine. Vikas engine is being used.
Earlier this month, National Security Advisor Ajit Doval and Roscosmos Director General Dmitry Rogozin in Moscow also discussed rocket aerodynamic tests for the Indian crewed flight carrier and also the piloted vehicle and crew rescue system. Another top-level meeting between Russia and India is likely to be held during the Eastern Economic Forum from 4th September to 6th September in Russia's Vladivostok, where the two sides are expected to discuss on cooperation in the sphere of piloted space flights, satellite navigation and engine technology.
As India's space program is concerned, there has been a substantial amount of assistance provided by a few countries, and Russia is one of the countries which has been since the days of Soviet Union assisting India with its space program. So this is a continuation of a Russian policy to assist India into the space domain. And semi-cryogenic engine is one technology which India has already started working on it. So definitely now with Russia's assistance, India will be able to develop it slightly in a lesser amount of time.
India and Russia are also discussing setting up ground stations in each other's countries to enhance the accuracy of their satellite navigation signals. ISRO wants to set up its ground station for the Navig system in Russia, while Russia in turn wants to set up a ground station in India for its satellite navigation system. The Russian ground station will be in Bengaluru, while the Indian station is likely to be in Moscow. Cooperation in space has emerged as a key area of cooperation in the high technology sector between India and Russia. In October 2019, during Russian President Vladimir Putin's visit to India, the two countries signed an agreement on joint activities in the field of human spaceflight program. Both countries emphasized the importance of mutually beneficial cooperation in outer space and agreed to further intensify cooperation in exploration and use of outer space for peaceful purposes, including human spaceflight programs. Bureau Report, Rajya Sabha TV. Rocket engines need enormous thrust to escape Earth's gravitational pull. However, the chemicals used for engines, hydrogen and oxygen, that produce a good thrust are found on Earth in the form of gas. Carrying the amount of fuel for a rocket, to undertake its journey will mean undertaking the impossible task of sending huge tanks of hydrogen and oxygen gas into space. So the solution is to use hydrogen and oxygen in their liquid form, which is easier to transport. As density increases in liquid form, more thrust can be produced in smaller burning time. Such engines are called cryogenic engines. In our next report, let's tell you the difference between a cryogenic and a semi-cryogenic rocket engine.
A cryogenic rocket engine uses a cryogenic fuel or oxidizer, which means that its fuel or oxidizer or both are liquefied gases stored at very low temperatures. Cryogenic fuels are used in space machinery like rocket ships and satellites because ordinary fuel cannot be used in space due to the absence of an environment that supports combustion. These fuels require storage at extremely low temperatures to maintain them in a liquid state. Cryogenic fuels most often constitute liquefied gases such as liquid hydrogen.
If you look at the entire launching sequence of any spacecraft, it is used by a rocket launcher. When India launches its GSLV, that is Geostationary Launch Vehicle, this vehicle uses a pattern of a three-stage launching. The first stage is a solid stage, second stage is a liquid stage, and a third stage is a cryogenic stage. Cryogenic stage is essentially used because it produces a lot amount of a thrust so that you can carry more weight and you can put that weight into a higher orbit. So India has developed this technology for a certain amount of a time. Now to develop it further and to carry more amount of a weight and take it to a higher altitude, you require a combination. Instead of a solid, liquid and a cryogenic stage, you require a combination of a solid, cryogenic and a semi-cryogenic stage. So this is what now Russia is offering, the advanced version of a cryogenic technology called semi-cryogenic technology.
While a cryogenic engine uses a combination of liquid hydrogen and liquid oxygen as propellant, the semi-cryogenic engine uses refined kerosene instead of liquid hydrogen. The liquid oxygen is used as the oxidizer. That's the advantage of using a semi-cryogenic engine, as it uses refined kerosene, which is lighter than liquid fuel and can be stored at a normal temperature. The combination of liquid hydrogen and liquid oxygen is heavier and has to be stored at freezing temperatures of -253 degrees Celsius. Despite being a lighter fuel, however, kerosene combined with oxygen gives a higher thrust. Kerosene also occupies lesser space, making it possible to carry more propellant in the semi-cryogenic engine's fuel compartment. A semi-cryogenic engine is more powerful, environment-friendly and cost-effective as compared to a cryogenic engine. These engines are usually prepared for the upper stages or the last stage of the rocket.
If you use this engine, the fuel will come down by about 500 kgs. So, which means that your payload can be increased. And the deep throttle, you can go from 27% to 105%. Whereas the ISRO, what ISRO is planning, the semi-cryogenic engine 200, you can go only from 60 to 105. So, which means your operability will be much higher.
The semi-cryogenic engine, or the SCE-200, is India's liquid fuel rocket engine, which is presently under development. It uses liquid oxygen and RP1 kerosene in an oxidizer-rich staged combustion cycle. Being developed by the Liquid Propulsion Systems Center, SCE-200 is expected to power ISRO's upcoming Unified Launch Vehicle, the ULV, and the Reusable Launch Vehicle, the RLV. It is also meant to power the future GSLV Mark III rockets. SCE-200 stands for semi-cryogenic. The 200 in the designation denotes its power of 200 tons. The project was approved by the Government of India in 2009 at a sanctioned cost of 1,798 crore rupees. Although the idea was to develop the technology in 2014, the project got delayed. ISRO is now planning to flight test its semi-cryogenic engine by 2021. Bureau Report, Rajya Sabha TV.
Russia has played an important role in India's space journey. In fact, space remains one of the key pillars of the strategic partnership between India and Russia. And over the years, India's indigenous space program has benefited from Russian technical and scientific assistance. In our next report, we talk about how the collaboration between India and Russia has expanded over the years.
For decades now, space has been one of the pillars of the Indo-Russian strategic partnership. Over the years, India's space program has benefited from Russian technical and scientific assistance. The Indian Space Research Organization and the Soviet Academy of Sciences for the first time signed a contract to launch India's first national satellite, Aryabhat, in 1975. Under the agreement, Soviet provided consultation on the design and construction of the satellite. It also provided the satellite launch facility, while the Indian side was responsible for the production of the satellite. This satellite project led to Bhaskar 1 and 2 satellite launches in 1979 and 1981.
Russian Space Agency, or before that the Soviet Union, the Space Agency of the Soviet Union has been having really a very wonderful, fruitful cooperation with India for quite a long time. In fact, the first Indian to go to space, Rakesh Sharma, was taken in a Russian vehicle, Russian rocket, Russian vehicle, Russian program, right? So similarly, there have been many technology transfers. One of the most important technology transfer has been the cryogenic technology. Although the original Russian cryogenic engine were not much of use to India for ISRO's purposes, but the technology was taken from them. We reverse engineered it, we created those engines, we learned the whole technology, and then we have been able to better off it.
In 1988 and 1991, the Soviet SLV Vostok rocket launched India's imaging satellites, despite India developing its own satellite launch vehicle in 1987. After the dissolution of the Soviet Union, India and the Russian Federation started a new era of space collaboration. By early 90s, India became self-reliant in delivering its satellites into orbit through its Polar Satellite Launch Vehicle. To launch its satellite in geostationary orbits, India signed an agreement with approached Russia in 1992 for engines and technology for production in India. However, due to US concerns that it would trigger the arms race in the region, India and Russia renegotiated the deal in 1994 with no transfer of technology from Russia to India. India then negotiated procurement of 7 engines from Russia that were used in Indian GSLV Mark I launcher. During Russian President Vladimir Putin's visit to India in December 2004, the two countries signed two space-related bilateral agreements. They included the Intergovernmental Umbrella Agreement on Cooperation in Outer Space for Peaceful Purposes and the Inter-Space Agency Agreement on Cooperation in the Russian Satellite Navigation System, GLONASS. India and Russia also negotiated cooperative measures under the Global Navigation Satellite System, the Russian version of the Global Positioning System, and the Chandrayaan-2 projects. Though both these projects could not materialize, India and Russia agreed in 2011 to grant the Indian military preferential access to positioning data under GLONASS. Patent on Russian-supplied engines, India successfully tested its own cryogenic technology in GSLV Mark II launcher in 2014. In 2015, ISRO and Roscosmos signed a new MOU to expand cooperation in exploration and use of outer space for peaceful purposes.
As far as Russia is concerned, particularly in the arena of cryogenic engines, there has been a technology share which is happening since early 1990s. In fact, India's entire cryogenic engine program got delayed because early 1990s, when Russia was supposed to transfer this technology to India, Russia was put under tremendous pressure by the USA, saying that by selling this technology, you will be violating the guidelines of a MTCR, that is Missile Technology Control Regime, and please don't share or transfer the technology to India. That time Boris Yeltsin was in chair, and he succumbed to the pressure, and the technology was never transferred to India. Instead of transferring a technology, 6 to 7 engines were transferred to India, which were already made into Russia. So India has been using these engines for certain amount of missions. Subsequently, over a period of time, India has developed the cryogenic technology on its own, and now India is already making an attempt to develop the semi-cryogenic technology.
When the Russian President and the Indian Prime Minister met at the BRICS Summit in 2016 in Goa, they reaffirmed their commitment to pursue the immense potential to cooperate in the outer space to advance socially useful applications and scientific knowledge. India has an ambitious space program and is collaborating with many other countries apart from Russia, like France, Germany, Israel, and the US in this regard. Bureau Report, Rajya Sabha TV.
Prime Minister Narendra Modi announced plans to launch a manned mission to space in his Independence Day speech during his first term. Funding was promised and India's dreams took flight. The spacecraft that will take 3 Indian astronauts to space, the Gaganyaan, is planned to be launched in 2021. In our next report, let's tell you all about India's crewed orbital spacecraft Gaganyaan.
2022 जब आजादी के 75 साल होंगे, तब यहां हो सके तो उससे पहले आजादी का 75 साल मनाएंगे। तब तक मां भारत का कोई संतान, चाहे बेटा हो या बेटी, कोई भी हो सकता है, वे अंतरिक्ष में जाएंगे, हाथ में तिरंगा झंडा लेकर के जाएंगे। आजादी के 75 साल के पहले इस सपने को पूरा करना है।
When Prime Minister Narendra Modi made this announcement just a little over a year ago, it was the unveiling of an ambitious plan. By the year 2022, India will send an astronaut to space on board the Gaganyaan. And with that, India will become only the 4th nation to do so after the United States, Russia and China. Gaganyaan is an Indian crewed orbital spacecraft intended to be the basis of the Indian human spaceflight program. The spacecraft is being designed to carry 2 to 3 people. Gaganyaan will be launched on ISRO's biggest rocket, the GSLV Mark III, from Sriharikota. In its maiden crewed mission, the 3.7-ton capsule will orbit the Earth at an altitude of 400 kilometers for up to 7 days with a 3-person crew on board. Its service module is powered by 2 liquid propellant engines. The space capsule will have life support and environmental control systems. It is equipped with emergency mission abort and emergency escape that can be done at the first and second stage of the rocket. The mission is estimated to cost around 9,000 crore rupees. The spacecraft will be monitored 24/7 from the ISRO Telemetry Tracking and Command Center in Pune. The spacecraft will be smaller than the current Russian and Chinese ones, NASA's planned Orion spacecraft or the past Apollo capsules, but slightly larger than the past US Gemini spacecraft. Describing it more as a national mission than ISRO's alone, the agency said it has developed most of the critical technologies needed for the mission. ISRO will set up a full-fledged training facility in Bengaluru to train astronauts. The test or crew escape system is an emergency escape measure that helps pull the crew away from the launch vehicle when a mission has to be aborted. India plans to call its astronauts Vyomnauts since Vyom in Sanskrit means space. Preliminary studies and technological development of Gaganyaan started in 2006 under the generic name Orbital Vehicle. The plan was to design a simple capsule similar to the Mercury-class spacecraft with an endurance of about a week in space. It was designed to carry 2 astronauts and to land in water upon re-entry. The design was finalized by March 2008 and was submitted to the Government of India for funding. Bureau Report, Rajya Sabha TV.
So we have the spacecraft, but what about the other things that need to be kept in mind for a manned flight into space? From the spacecraft to astronauts training, everything needs to be precise for this dream to take flight. For a spacecraft to re-enter the Earth's atmosphere, it needs to be able to withstand high temperatures, which involves special parameters for the craft. Even the astronauts traveling into space need special physical and mental training for the flight. So in our next report, let's take a look at how ISRO is preparing for this ambitious mission.
Satellites launched by ISRO are meant to remain in space even after their life is over. Even the Chandrayaan and Mangalyaan are not meant to return to Earth. But not Gaganyaan. As a manned spacecraft, it needs to return with the human beings inside it. This involves mastering the complicated process of re-entry and recovery. Re-entry will mean the spacecraft needs to withstand very high temperatures created due to friction. Also, the spacecraft needs to re-enter the atmosphere at a very precise speed and angle. On December 18, 2014, the GSLV Mark III successfully tested an experimental crew module that came back to Earth from an altitude of 126 kilometers into space. Called the Crew Module Atmospheric Re-entry Experiment, it re-entered the atmosphere at a height of 80 kilometers and landed in the sea near the Andaman and Nicobar Islands. The third technology is the emergency escape mechanism for astronauts. The crew escape system ensures that the crew module gets advance warning if anything goes wrong with the rocket. It pulls it away to a safe distance, after which it can be landed either on sea or on land with parachutes. The crew module is a twin-walled, sealed structure that recreates Earth-like conditions for astronauts. The first challenge for any astronaut is negotiating the change in the gravitational field. Transitioning from one to another affects hand-eye and head-eye coordination. Without gravity working on the human body, bones lose minerals, putting astronauts at risk of osteoporosis-related fractures. Lack of exercise and improper diet makes them lose muscle strength and even develop vision problems. The second challenge is the travel within the rockets. It's unlike any travel that normal people experience. Rockets achieve a speed from 0 km per hour to 29,000 km per hour in less than 30 minutes. Rockets often disintegrate in the launch phase itself, despite the many inbuilt safety features. Moreover, no system can be tested in actual operating environments. Once they are in space or in space stations, astronauts get over 10 times radiation than what people are subjected to on Earth. Radiation causes cancer, damages the nervous system, triggers nausea, vomiting, anorexia, and fatigue. Innumerable movies have shown that space is hostile. It has no atmosphere. Without pressure, human blood heats up. Space vehicles need to have an atmosphere like Earth, ensure adequate supply of oxygen along with comfortable temperature and humidity levels. Lastly, despite all the training, behavioral issues crop up due to isolation. Astronauts could encounter depression, fatigue, sleep disorders, and psychiatric disorders. Bureau Report, Rajya Sabha TV.
So that's it from us today in depth. We'll be back same time tomorrow with a detailed analysis on some other subject. In case you missed the television broadcast, you can also watch our program online on YouTube and Twitter, the link for which is given below on your screens. Suggestions and feedback about the program are also welcome. Thank you very much for your time.